So the compound given to us in this question is ester. So what is an ester? Well, yes, it's one of the functional group in organic chemistry, but it is equally important to know that the esters are one of the derivatives of carboxylic acids. We all know the general formula of carboxylic acid is COOH. And the carboxylic derivatives are the compounds in which the OH group of carboxylic acid has been replaced. So for example, when the OH is replaced by chlorine, then that is called acid chloride. When the OH is replaced by OOCr, then that is called anhydride. And when the OH is replaced by NH2, that is amide. And when the OH is replaced by OR, then that is ester. Esters are prepared via two main ways. Either they are formed from the reaction between carboxylic acids and alcohols in presence of concentrated H2SO4 is the catalyst, or esters form alcohols with acid chlorides with a catalyst. However, in general, we could tell that they are formed in the reaction between an alcohol and an acid. The acid could be a carboxylic acid or an acid chloride. So now, before we jump into the reaction, I believe it is quite crucial to know how to name this compound, for it will help you to figure out the two parts in the ester without any confusion. So there are two parts in the name of the ester. The first part consists of the part of the name of the alcohol used to form the ester, which ends with the suffix -il, whereas the other part consists of part of the name of the acid or the acid chloride used, which ends with the suffix -oate. So here we have CH3CH2 COO CH2CH3. This is called ethyl propanoate, and we have HCOO CH2 CH2 CH3. This is propyl methanoate, and we have CH3 CH2 CH2 C double bond O OCH3, that is called methyl butanoate, and we have CH3 C double bond O OCH2 CH2 CH3, that is propyl ethanoate. So accordingly, the name of the compound given to us in this question is methyl propanoate. Now it's pretty safe to move into the reaction part of the question. Alright, so the characteristic type of reaction that carboxylic acid derivatives undergo is hydrolysis. Technically, hydrolysis is a reaction with water. So basically, the hydrolysis of esters falls under two categories. Firstly, hydrolysis of esters with dilute acids. Secondly, hydrolysis of esters with dilute alkali. So hydrolysis of esters with pure water is very slow reaction, so we can gracefully disregard it as it's never used. In hydrolysis of esters with dilute acids, the reaction is catalyzed by dilute acid, and in here the ester bond splits into its respective carboxylic acid and alcohol is the product. For example, here we have RC double bond O OC2H5 plus H2O with H plus, so that is for dilute acid. So the products are RCOOH, that is carboxylic acid, plus C2H5OH, that is alcohol. Whereas in hydrolysis of esters with dilute alkali, the products are its alkali salt and alcohol. Unlike in the hydrolysis of esters with dilute acids, we don't get the split of carboxylic acid and alcohol. Instead, we get the alkali salt and the respective alcohol. Common example for that is using aqueous NaOH. So here in this example, we have RCOOC2H5, NaOH, and we have products RCOO minus Na plus. That is the alkali salt, and we have C2H5OH, that is the alcohol. Now we are pretty convinced about the answer to our question, and that is the fourth one.